Hi students, now we will see about the importance of center of gravity and moment of inertia. Okay, so already you have studied in your school days. What is the centroid? Will you please tell me what is the centroid? It is a geometrical center of the body. Okay, it is assumed to be acting with the centroid. Center of gravity. What is the center of gravity? Point at which the whole entire weight of the body is acting. Okay, wow. So here, if you are taking that centroid, it depends upon what are the factors: length, area, and volume. So here, the center of gravity, it is the center of the mass. Okay. So and also just we know that it is depending upon the shapes also. So what is the symmetrical section? Yes, it divides the whole figure into two equal parts. Okay, so if it is in it may be in one axis or it may be in both the axes. So if I am taking this square is symmetrical about both the axes. Here this I section similar both the axes. Here T section only y axis. Okay, so it is the symmetry will be depending upon the given shapes, and also here you can see the centroid of the different shapes. So you have studied that. Now we will see the moment of inertia. So now getting into this, first you should know that what is the moment of inertia and what are the factors which are involved. Okay, and what is the significance, application. So everything we will see in this session. Okay, so now first we will see that what is the moment of inertia. It is the resistance to rotation. Okay, so if I am taking some plane area, so how will you calculate the moment of inertia? It is nothing but integration of y square into dA or x square into dA. So what is the letter we are denoting I? Moment of inertia is represented by letter I. Okay. So and what are the factors which are involved here? Density, shape, size, and axis of rotation. Okay, wow. So if the density is varies, the moment of inertia will get varies. Shapes, there are different shapes are there. For an example, rectangular, circular, square, quadrant, semicircle, ellipse. So many shapes are there. The shapes also very important. Okay. So now, what is the significance? What is why we are studying as civil engineer? Why we are studying this? So, to calculate the bending stress calculations. Okay, and next, yes, structural stiffness. Okay, next one, beam and column design. Okay, so these are all the significance. Okay, and if I am taking some a system of particles. Okay, so there are so many particles are there. If it is having a mass of m1, m2, m3, and it is at a distance of r1 and r2, r3 respectively, how will you calculate the moment of inertia? The summation of mi into r. That is a mass into it is a summation of product of mass into distance. Okay, square distance. Okay, and if I am taking this, it is a rigid bodies. So if it is a plane area, that is a formula. If I am taking the plane, rigid bodies, then the formula is integration of r square into dA. Okay, dm. So if I am taking a rigid body, you will consider one small element. You will calculate the moment of inertia for that small element, and then if you are integrating, we will get it for whole body. So what are the applications? There are so many applications. You can see that. So in beam designing of beam, here whenever if I am placing this beam like this, the moment of inertia will be different. If I am placing this, the moment of inertia is different. Okay, so here we will place the beam like this. How will you decide? By calculating the moment of inertia itself, we can design the position of the beam in the structures. Okay, and if I am taking this, the another application is stability checking. So here, when the boat is sailing in the river or anything, okay, already we were discussed. If the persons are sitting, equal weights are there in both the places. Okay, then CG will be at center. Then the boat will be. So now if I am taking the boat, okay. So here whenever the boat is sailing in the river or thing, and the water will create some force. That is a buoyancy force. So whenever the CG is equal to the buoyancy force, then the boat will be in equilibrium. Okay. So next, what are the day-to-day where we are using. You can see the satellites moving. Okay, then that is if you are driving the vehicle in the curved path or maybe straight line, and then falling off fruits and leaves from the trees, and dusting a carpet. So there are machines. So every part of the day-to-day life we are using this. Directly we are using the center of gravity and moment of inertia. So as a civil engineer, you should know these topics. Okay, so then only we are going to use software for designing the structures. You will do that. You will study that subjects in next year. Okay, so for that subject, this topics are very important. Okay, so thank you. So we will see the next topic in